Hi, I'm budding researchers, and welcome to another episode of Research Bite Size. So we are still understanding quantitative data analysis. I hope that you were able to understand clearly other tests, statistical tests focusing on quantitative data analysis. Now, this time, going back to our favorite case study about EPs, flying EPs. So, focusing on this question, are Athenians more anxious when they see a real cockroach than seeing a picture of it? And you looked at the main question focusing on the independent variable, a real cockroach and a picture of cockroach. And the dependent variable, obviously, is the anxiety level. So I hope this is clear how we analyze also the variables given a specific research problem. Now, this is my question to you. Is it possible for us to apply statistical analysis when our IV, the independent variable, has 3 or more levels? I'm not saying you have 3 independent variables. It means you only have one independent variable, but that variable can be up to three levels. Now, compared to if you consider this question to the previous scenario on the flying EPs, so you have one variable and that is the presence of cockroach, but you have 2 levels. One is real cockroach and the other one is picture of cockroach. So with this, the answer, yes. So that's the reason why we have the one-way analysis of variance, or simply ANOVA. Now, why is variance essential in quantitative research? Now, when we talk about variance, I hope this is already clear. The concept is clear to you because you need to have a good spatial skill to really understand how spread your data, the data that you were able to gather. So when you talk about variance, it's a measure of how spread out or dispersed the scores are from the mean. So we still look at the mean scores. And focusing on these illustrations, so we can say that this one has a low variance because of the narrow spread of scores, and this one has high variance. So it has a wider spread of scores as compared to this illustration. Now, let me just give you a simple framework that you can apply in choosing the right statistical test for comparing means. So if you have a dependent variable, a categorical DV, and the other one is a continuous DV. So if it's categorical, you can apply directly chi-squared test. So we will just discuss this one later on. And then if the dependent variable is continuous, and if you only have either one IV or 2 independent variables, so focusing first on the one independent variable, now does it have 2 levels or does it have 3 levels? So what will happen here? So having 2 levels, you can apply independent means or a paired means. So independent samples t-test or a paired samples t-test can be applied here. So having 3 or more levels, so you have a one-way ANOVA statistical test. And if you have 2 independent variables, that's the time you will now explore two-way ANOVA. So just to emphasize, what we are focusing here is just one IV, but there are 3 levels on the independent variables. So this is our pathway. Now, so what is ANOVA? So simply it's analysis of variance, and it tests equality between 2 or more means using independent groups. And when you apply, when this is applied to only 2 groups, the one-way ANOVA is identical to the two-tailed test for independent samples. So we can say that ANOVA is an extended t-test. So one-way ANOVA examines now associations between a categorical independent variable, so having 2 or more groups, and a continuous dependent variable. So just to establish the conceptual understanding, is there a significant difference in the number of friends of grade 11 ASHS students? So let's explore this research problem by not integrating yet data, but just to reinforce your conceptual understanding of analysis of variance so that you have a good grasp of visualizing ANOVA. So again, this is our problem. So in terms of number of friends of grade 11 senior high school students. So ANOVA allows us to evaluate if there is a significant difference between more than 2 means. So what are the population? Again, you have the ABM strand, GA strand, Hume strand, and the STEM strand. So why not conduct multiple t-tests? So such as ABM versus GA, ABM to Hume's, ABM then STEM. So you compare now the mean scores, the number of friends that they have, GA Hume's, GA STEM, Hume STEM. Why not do it that way? So the reason for this one, aside from it being a tedious task, ANOVA, take note, keeps the risk of type 1 error small. So it will make you less prone to committing type 1 error. What is type 1 error again? It's false positive. So each t-test will have a type 1 error rate. And doing multiple t-tests now will increase the overall type 1 error rate. So we need to avoid that kind of situation. That's why we have the ANOVA, in order to lessen the type 1 error risk. So now we are concerned about two types of variances. What are these two types? You have variation between groups and variation within groups. So when you talk about variation between groups, this is distance or deviation of group means from one another, same population. And then variation within groups, it's the distance or deviation of raw scores from their group mean. So I think I said it reverse. But I'll try to illustrate this one, the description. So here, so distance of group means from one another represents now you have population of humes, stem, and then the GA. So this is the mean score. So this is what we talk about variation between groups, this one. And when we talk about variation within groups, so having within the same population, so this is the distance of raw scores from their group mean. So that's what we refer to as the variation within groups. So comparing means using ANOVA entails an analysis of the ratio between groups variation and within groups variation. So looking at the illustrations earlier, so we try to compare and analyze the given variances. So given this scenario, how do we interpret now? So you have between groups and within groups. So between groups variance, take note, is larger than within groups variance. So you can see the distance, right? Or having this kind of data, the between groups variance now is smaller than within group variance. So that's how we wanted to picture the distribution of data, how spread the data is. And that's how essential also ANOVA as a statistical test for us to really represent these results. Now take note, the variation between groups, so spread of means between groups, it's the effect of treatment or the condition of or the independent variable. While the variation within groups, that refers to the error. So having this concept, we can now consider the effect over error as we call it the test statistic. So in ANOVA, we compare the size of the between groups variance relative to the within group variance. So having this equation now, we can now consider this as the F ratio. So you'll find out later you have the F. So simply that is variation between groups over variation within groups. So we call it the F ratio. So we compare the size of the between groups variance relative to the within groups variance. So what are the components of F ratio? So F ratio components, you have sum of squares or sum of square deviations from the mean. And then you also have degrees of freedom, and you also have the mean square. And the mean square simply it's sum of squares over the degrees of freedom. So that's the mean square. So what are the assumptions in using one-way ANOVA as a statistical tool? Take note of the following. So in terms of data, so the IV is considered as categorical and has 2 or more levels, and the DV is continuous. If it only has, I think, 3, that's ideal for one-way ANOVA. So 2 levels, you can apply independent samples t-test there actually. So independence also, each observation of the DV is independent of the other observations of the dependent variable. So the score of one participant does not influence another. And in normality also, so the sampling distribution of the differences between means should be normally distributed before we use ANOVA. If it's not normally distributed, then we can use another statistical test. Then for the homogeneity of variance, the variance should be the same across groups, so coming from populations within the same variance. So with that, I hope everything's clear how we demonstrate ANOVA using SPSS. And please do take note of all this conceptual understanding of one-way ANOVA.